Okay, we are recording. The mic is on. Okay, so y'all, this is week 3. I hope everybody's been doing okay. I hope you guys had a nice Monday off, at least from school, because it was Labor Day. Oops, let me do this so everybody can see what I'm looking at. There you go. Okay, so y'all, today we have one section to do. We're going to cover section 2.3. I am recording the lecture, y'all, so I will upload it by 5 o'clock today. And section 2.3, y'all, is not due until next Wednesday, which is the 14th. Friendly reminder, y'all, 2.1 and 2.2 are due by this evening. Okay, so if you haven't yet finished 2.1 and 2.2, they are due by tonight, so just don't forget. And then there is a quiz over chapter 2, y'all. And for the quiz, y'all, I think the last time I had said you had 2 attempts, it was really 3. So you got 3 attempts at the quiz here too. You have 90 minutes to finish the quiz. If you're happy with your grade, y'all, either after the first time or after the second time, you don't got to take it again, okay? It's just that you have 3 tries. You know, if you want to use all 3, that's fine. I always take the highest grade out of all 3. So whichever one, you know, is good with you. But if you take the quiz the first time and you're good with your grade, don't worry about the next 2 attempts, okay? It doesn't hurt you if you don't do it. All right, so anywho, let's go ahead and finish or go through section 2.3. So let me grab my notes over here somewhere. That's not us. That's not us either. I believe this is probably us. Here we go. 2.3, here we go. 2.3, y'all, talks about these things called Venn diagrams and set operations, okay? And so Venn diagrams, we've done a little bit of Venn diagrams, but we have a rectangle. We call it the universal set U, right? It's all about U, universal set. And then we take that rectangle and we break it up into pieces, and we call those things subsets. And the subsets are usually represented by circles. So what I have right here is my universal set U in the rectangle, and the subset of U, which is the set A that's in the circle. Why is my pen not working? There we go. Okay. So we got our universal set U, and then A is a subset of U, right? So we might say something like, come on, pen. A is a subset of U. Okay. Now we have something called disjoint sets. Disjoint sets are 2 sets which have no elements in common. They're said to be disjoint. So if they don't have anything in common, so like the way when again, just looking at this picture right here, my sets A and B are disjoint because they have no overlap, right? There's nothing in A that's also going to be in B, okay? We had something the other day, we talked about proper subsets. So proper subsets, if you remember, we have it written like this: A is a proper subset of B. All that meant, y'all, is that everything in A is also in B, but that B has at least one extra thing. It can have a bunch of extra things, but it's got to have at least one extra thing in there, okay? So let's see. I'm just kind of go on until we actually get to some problems, but I'm just kind of going through some basic definitions here. Equal sets. So we talked about equal sets before too. They're equal if they have the same exact elements. So when we draw it as a Venn diagram, the circle for A and the circle for B, it's just the same circle, right? Because the 2 sets are equal. And then overlapping sets. Overlapping sets looks like this. So there is some overlap. There's something that both that A and B have in common. It can be one element, it can be one thing, it can be like 90 things, okay? As long as they have some stuff in common, then we say they're overlapping sets, okay? And this is how we draw overlapping sets. So you can see the circles for A and B overlap each other, right? Okay, so we have something called the complement of a set. So the complement of set A, symbolized by A with an apostrophe. Sometimes, and we're gonna do some problems like this too. Sometimes they write it with A with a little bar on the top. Both those things mean the complement. Whether we use A with the apostrophe or A with a box or a little line, on top of it, they both mean the complement. And the complement is everything that's in the universal set that's not in the set A. So basically, A complement says, give me everything that's not in A, okay? And we're going to do an example of that right here. So I got a problem here, and it says, given, here's my universal set, y'all. The universal set has the letters A, B, C, D, E, F, G, and the set A has the letters A, C, and E. What we want to do is we want to determine a complement and illustrate the relationship among the sets U, A, and A complement in a Venn diagram. Okay, so the easiest way for me to do this, y'all, is I'm going to draw a Venn diagram. So I'm going to draw a big rectangle, right, kind of thing right here. And then inside that rectangle, y'all, I'm going to draw my set A. Now, I want you to look at the set A. Look at the letters that are in the set A. The letters are in the set A are the little letters A, C, and E. So inside here, you guys, I'm going to write A, C, and E. Okay. Now, the big rectangle is our universal set. So everything is going to have to fall inside that rectangle box. Okay. I'm not going to write any letters outside the box. Everything's going to be inside the box. Now, since we have already used the letters A, C, and E, we can see the letters that we have left are B, D, F, and G. Now, those letters are inside the universal set. They're just not inside the circle A. So I'm going to write B, D, F, and G. Okay. And so those letters there, right there, y'all, the ones we just wrote, would be what we call our A complement. Okay. They're everything that's inside the universal set that are not in the set A. Okay. So everything outside over here, y'all, everything outside this circle would be our A complement. Okay. It's everything that's the universal set that's not in the set A. All right. Okay, so I'm going to kind of keep scrolling along here. And we're going to talk about something called the intersection of sets. Okay, so we talked about before, y'all, when sets overlap. So when we have sets that overlap, this little symbol, like this kind of upside down U, that's what we call the intersection. Okay, we call that the intersection. The intersection is just saying, what elements do we have in common to both sets A and B? Okay, what sets do we have in common both into A and B? Okay, so you can see this right here, this little overlap. This little overlap right here is what we call the intersection. Okay, that's how we draw that picture. So what I'd like for us to do is I'd like for us to go through this problem here. And we have a few sets here. So U is our universal set. It looks like it has the numbers, the counting numbers 1 through 10. A is a set of the numbers 1, 2, 3, and 8. B is a set of the numbers 1, 3, 6, 7, and 8. Does anybody know what the set C is? Anybody remember what we call that set? There's nothing inside it. Anyone remember? That's what we call the empty set. The set that has nothing there, okay? All right, so let's go through our problems. We got 4 of them here. And the first one says we're looking for the set of A intersection B. Okay, what A intersection B, y'all, means is let's look at the set A and let's look at the set B. And what we want to know is what numbers do we have in common? What numbers appear both in A and in B? Anybody know? 1, 3, and 8. Perfect. There you go. There's the intersection of the two sets. All you're looking for are the numbers, I'm sorry, in this case numbers because they're numbers, that we have in common. Okay. So look, let's do the same thing for part B. Part B says we're looking for A intersection C. So what I'm doing now, y'all, is I'm looking at this set here, and I'm looking at this set here. And the question is, do they have anything in common? No. When they don't have anything in common, y'all, the answer is just the empty set. There's nothing in common, right? So I'm just going to write it like that, okay? Now, there is a part C, so let's do part C. Part C says we're looking for A complement intersection B. So y'all, the first thing I want to do before I do this part right here, I need to know what does the set A complement look like? Well, if I already know what the set A looks like, I bet you we can find the set A complement. A complement says, I want to find, oops, sorry, there we go. A complement says, I want to find the numbers that are here, but not those numbers. I don't want to use those. I don't want to use 1, 2, 3, or 8. So if I'm going to pick the numbers that are here that are not the numbers 1, 2, 3, or 8, does anybody know what would be the first number we would start off with? 4, right? We'd say 4, 5, 6, 7, not 8, but 9 and 10. Okay. So there's my set A complement. Okay. Now what I want to do, y'all, I want to look at this set here, A complement, and B, this set right here. So I'm looking at this one and that one, and we're trying to find what are the numbers that we have in common. Do we have any numbers in common in those two sets? In B, which is 1, 3, 6, 7, 8, and in A complement, which is 4, 5, 6, 7, 9, and 10. What numbers do we have in common? 6 and 7, right? And there's our complement, okay? So y'all, for me to do part C, I want to point something out. When part C says we want to find the intersection of A complement and B, in order for me to do that, I have to know, well, what does A complement look like? So I actually have to do that little think of that as scratch work. I got to do that part first. And again, how do we find A complement? The way we found A complement was we said, I want to find the numbers that are in U, but I don't want to use the numbers 1, 2, 3, or 8. So we said, look, let's scratch out 1, 2, 3, and 8 and look at the numbers we were left with, 4, 5, 6, 7, 9, and 10, which is what we had right there, right? And then we said, okay, now let's look at this set here, and let's look at B right here. And then let's find the ones that we have in common, all right? Okay, so we have one last part, y'all, to do, part D. Okay, so part D says we are looking for A intersection B complement. Okay, so in order for us to find A intersection B complement, what we're going to do, you guys, I'm going to come back over here. I'm erasing this stuff because I want to keep making sure that I have access to this. But what I'm doing is I'm going to look at my universal set right there. Okay, now, just like we would do like in a regular math problem, we do what's on the inside of the parentheses first. Here's the inside of my parentheses. It's A intersection B. But we did A intersection B. We did that in part A. So what we want to do, since we're going to find the complement, we want to pick all the numbers that are in my universal set except for the numbers 1, 3, and 8. So if we don't use the numbers 1, 3, and 8, then we're left with 2, 4, 5, 6, 7, 9, and 10. And that's what the complement means. The complement means go back to the universal set and pick all the numbers that were not in the original one, right? In the original A intersection B was 1, 3, and 8, so that's why we didn't want to use 1, 3, and 8. Does that make sense? Okay. All right, so I'm going to kind of keep trucking along here, y'all. If y'all got any questions, please let me know. I'm going to make sure that we're good. Okay. Now, we have something called the union of two sets, y'all. The union of two sets is the way we write it, it's like this. And so that regular looking U, I know it looks a little funny, but it's not upside down like the other way the other one was. That's what we call the union. The union says we're going to take everything in A, we're going to take everything in B, and even if they overlap, that's fine too. All of it together, okay? So I'm going to do another problem. It's going to be real similar. My universal set is still the numbers 1, or the counting numbers 1 through 10. My set A is now the numbers 1, 2, 4, and 6. Our set B are the numbers 1, 3, 6, 7, and 9. Anybody know what the set C is? Empty set, right? Cool. All right, so just to make sure that we remember, that's what we call the empty set. Okay, so look, y'all, we got a few problems to do here, and we're going to do these problems just like we did the other ones, real similar at least. So part A says we're looking for A union B. What A union B, y'all, means is let's take all the numbers that were in A, and let's take all the numbers that were in B, and let's throw them all in together. Now, if there's any overlap, we don't have to write them twice, okay? But we're all going to put them in there. So I see a 1. They both have a 1, but I only need to write it one time. I never have to write my numbers twice. We also have a 2, a 3, a 4. Do we have a 5 in either of those two? No, right? But we do have a 6, a 7, and a 9. So what did we do? We took everything in A, we took everything in B, we just threw them all in together. Again, we don't need to write the numbers twice. If one of them happens to be in both of them, a certain number like the number 1 or the number 6, we don't have to write it twice, okay? We just write it the one time. Okay, so now we're going to do the same thing for part B. Part B says we're looking for A union C. So remember what A union C means. I'm going to take everything in this set here, and I'm going to take everything in that set there, and we're going to write it as one set. Okay, so we're going to throw them all together. Now, y'all, I agree. There is nothing in here, right? It's the empty set. But we still have those numbers 1, 2, 4, and 6, right? We're throwing them all in together. And it's just in the empty set. There's nothing for me to put in there. Does that make sense? So I still got everything in the set A. Okay. All right, let's do part C. So part C, y'all, says we need to find A complement union B. So just like we did before, y'all, the first thing I want us to do is to find A complement. So remember, the way I'm going to find A complement is I'm going to look at my universal set, and I'm going to pick numbers that are in that set, but I don't want the numbers 1, 2, 4, and 6. I don't want to use those numbers. So look, I'm going to scratch those out. 1, 2, 4, and 6. So what numbers are we left with? What? 3? 3, what, 5? 7, 8, 9, and 10, right? I'm using all the numbers except for 1, 2, 4, and 6. All right. Okay, so now, y'all, now that we have that part, I'm just going to clean some of this mess up here because there's a lot of mess here. Okay, now what I'm going to do is I'm going to look at these numbers here in A complement, and I'm going to look at these numbers here in the set B, and I'm just going to throw them all in one big set. Okay, again, if they repeat, I'm not going to write them down twice. What do you think the first number I would need if I'm going to put everything in this set here and everything in that set there together? 1, right? And then the next one is what? Do we have a 2? No, but we have a 3, 5, 6, 7, 8, 9, and 10. There we go. All right, and there's our A complement union B. All we did, y'all, is put those two sets right here. These two sets, we just threw them all in together. Okay, and there is a part D, so we're going to do part D right now. So part D says, let's find A union B complement, okay? Now, y'all, the way we find A union B complement is we first have to know, what does A union B look like? Well, hey, we did that in the first part, right? That was my part A. We did A union B right here. So what we're going to do is we're going to look at those numbers, and we're going to come back to our universal set. I'm going to pick all the numbers in my universal set that were not the numbers 1, 2, 3, 4, 6, 7, and 9. So look, let's start scratching those numbers. 1, 2, 3, 4, 6, 7, and 9. So what numbers are we left with? Anybody know what numbers we're left with once we scratch those? Yeah, 5 and what? 5, 8, and 10? Oh, come on, 10. There we go. And there's our A union B complement. Okay. All right, so again, y'all, all I'm doing here is I'm just trying to how would I write those sets out? And union with the regular looking U just means throw everything together. But if we're talking about the intersection, which is like the upside down U, then what you're looking for are what are the ones that they have in common? Okay, which ones are in both pieces? All right. So I'm going to keep scrolling on here. Okay, so here we got a problem, and it's talking about the number of elements in A union B. Okay, so let's take a look, see here what we got. It says the number of elements in A union B is equal to the number of elements in A plus the number of elements in B minus the number of elements in both. Okay, remember that intersection means it's where they overlap, the both part, okay? So let's take a look at this first problem here, and let's see if we can figure out how we can use this formula right here, or this idea, to answer that question. Okay, so the problem here says the results of a survey of visitors at the Grand Canyon showed that 25 people speak Spanish, 14 people speak French, 4 people speak both Spanish and French. How many people speak Spanish or French? Okay, so what we're going to do here, y'all, we're going to say, look, we're looking for the number of people who speak Spanish or is kind of like that union, or French. Okay, so I'm looking for the number that speaks Spanish or French. Y'all, all I'm doing here is instead of me writing an A and a B, I'm using an S and an F for Spanish and French, right? So I might say, look, that's going to be equal to the number of people who speak Spanish plus the number of people who speak French minus the number of people who speak Spanish and French. Okay. So now all I'm going to do is kind of do a little plug and chug here. So do we know how many people speak Spanish? 25, right? Good. Do we know the number of people who speak French? 14. Excellent. And how many people speak both? 4, right? And so y'all, all I'm going to do is just do this part right here. So if I was actually combining these numbers, one thing I might do is I might say, look, let's do this part over here first. Oh, come on, pen. My pen's giving me so many problems today. Okay, so I might do that part first and say, what's 14 minus 4? 10, right? And 25 plus 10 is 35. So we got 35 people who speak either Spanish or French. Okay? And again, the reason why we do it this way, y'all, these 4 folks, if we didn't subtract them, we'd be counting them twice. Because when we said, do you speak Spanish? If you speak Spanish and French, you would have still said yes, right? Or we said, do you speak French and you speak both? You would have said yes. So we don't subtract it, then we're counting those people twice, okay? All right, I'm going to do the same thing here. It says, the results of a survey of customers at McDonald's restaurant showed that 28 purchased either a burger or fries, 20 people bought fries, 17 people bought both a hamburger and fries. How many people only bought a burger? I don't know. But we're going to see if we can't figure this thing out. So we're going to say, look, we're talking about people who bought either a burger or fries. So I'm going to go like this, burger or fries. And y'all, all I'm going to do is just kind of fill in the blanks, okay, using that little formula that we had before. Okay. Okay, now let's see if we can find some of these numbers to substitute. Do we know how many people bought either a burger or fries? Yeah, that first number, 28 of them did, right? So right here, y'all, I'm going to leave that as 28. Now, I don't know how many people only bought a burger. I don't know that yet. So I'm going to leave that alone. But do we know how many people bought fries? 20. That's 20 right here. Minus, do we know how many people bought both? 17. Okay. So look, y'all, I'm going to say that's 28. This is the number of people who bought a burger. Anybody know what's 20 minus 17? 3. Okay. So y'all, if I'm trying to find the number of people who only bought a burger, I'm just going to subtract 3 on both sides. Okay. And 28 minus 3 is 25. And that's how many people bought a burger. Okay. So again, all I'm really doing here, y'all, I'm just kind of walking through the process and trying to figure out what values I know and what values I don't know. Okay. So I'm just going to kind of keep trucking along here. Okay, and we have something called the difference of two sets. And the difference of two sets, y'all, is exactly how it kind of looks. If you look at it, it says A minus B, right? That difference means subtract. It says it's a set of the elements that belong to the set A, but not to the set B. Okay, so just to give you a visual of what it would look like, because in other problems, I did have a Venn diagram, in this one here, I don't. So I'm going to draw a Venn diagram just so we can kind of see what this looks like. Okay, here's my set A, and here's my set B. And that's what A minus B looks like. Everything in A, but if it was in B, get rid of it. We only want the stuff that was in A. So even though there's some overlap, we're not picking those numbers, okay? So, and it says also, look, y'all, it says right here, A minus B is the same thing as A intersection B complement. So this right here can also be written, or this is the same picture for A intersection B complement, okay? Just a little note, okay? Okay, so now I'm going to come back over here and I want to see if we can figure out each of these 4 parts. So when I do part A, it says, let's take A minus B. What A minus B says is I'm going to list all the numbers that are in A except those that also happen to be in B. So the way I'm going to do this, y'all, I'm just going to go one at a time. Is the little letter B also in B? Also in the set B, I should say. Yeah, it is, right? So I don't want to use that one. What about the little letter D? Is it also in the set B? Yeah, so I don't want to use that one. What about the letter E? Okay, so let's write it down. What about the letter F? Okay, so let's write it down. G? Okay, what about H? Yeah, so we don't want to use it, right? So there's my A minus B. I'm only picking the letters in A as long as they don't appear in B. And if they do appear in B, I'm not using them, okay? So look, there is a part B to this. Part B says, let's look at the set A minus C, okay? So again, y'all, I'm going to look at 2 sets right here. I'm going to look at A, and I'm going to look at C. And every letter that I'm going to write down should be in A, but I don't want to use the ones that were also in C. So I know I'm not going to use the letter B, but we can use D. I'm not going to use E, but I'm going to use F. And I'm not going to use G, but we are going to use H, right? Okay, so I'm just keep moving along here, y'all. Part C. Part C says we want to find A complement minus B. Okay, so the first thing I'm going to do here, y'all, before I do anything else, I need to know what is my A complement going to look like, right? So remember, the way I'm going to find A complement, I'm going to come back to my universal set right here. And I'm going to say, okay, I want to pick the numbers that are in the universal set, but are not letters in the set A. Anybody know what would be the first letter we would pick? A. Good. A. Not B, but we would pick C. Not D, not E, not F, not G, not H, but I, J, and K? Okay, so here's my A complement. So again, y'all, I'm using this piece right here, okay? And I'm going to say, I want to pick letters that are here that are not, oops, that's A, that are not in the set B, okay? So I want to pick these letters as long as they're not those right there. So I know I'm not going to pick A. Can we use C? Yeah, so let's use C. Very good. Can we use I? No, but we can use which other ones? There you go. J and K, right? Does that make sense how we're doing these? Anybody got any questions so far? Just want to make sure we're good. Okay. All right, so look, let's do part D. Okay, so part D says we're going to take A minus C complement. Okay, so y'all, just like we did before, the first thing I need to know is, yeah, what's that C complement or that C with a little apostrophe going to look like? Okay, so remember what C complement is going to be. It's going to say, let's pick all the letters that are here except for the B, E, and the G, right? So we're going to pick every letter except for B, E, and G. So we're going to start with A, not B, C, D, not E, but F, not G, but H, I, J, and K, right? Okay, so we found our C complement right here. Okay. Now, in order for us to do A minus C complement, what we're going to do now, y'all, is we're going to say, let's look at the set A. I just highlighted it for us. Let's look at those letters. We're going to pick those letters as long as they don't fall right here. So the first letter I see is B, and it's not in the C complement, so I'm going to go ahead and write that one down. The next one I see is D, but I can't use it. We can use E. We can't use F, but we can use G, and we can't use H because it's over here too, right? So A minus C complement was just the letters D, E, and G. All right. So I'm just going to kind of keep trucking along here, you all. And let's take a look and see what we got here. And so the next problem here, y'all, says for the sets U, A, and B, construct a Venn diagram and place the elements in the proper regions. Okay, so first thing I'm going to do, I'm going to draw a big rectangle. Okay, that's our universal set. And then I'm going to draw two circles, A and B. Okay, so I'm going to call this one A, and I'm going to call this one B. And which one you call A and B, it doesn't really matter. You can put B first and then A. It's not really important. Now, the way we're going to make this Venn diagram, first, y'all, we're going to look for what letters do they have in common. What I mean by that is if I look at the set A and the set B, do they have any letters in common? What letters would you say they have in common for both A and B? What, B? Okay, so the B, it's going to go right here in the middle. Why? Because that's where they overlap. Okay, what other letters do they have in common? I'm sorry, what was it? F? F and J? F and J. So look, we've used F and we've used J. So what I'm going to do, y'all, I'm going to scratch those letters out because I don't want to use them anymore. Okay. Now, to write the other letters that are in the set A, so we still have some other letters in the set A, we're left with A, E, and H. Those letters are going to go in the A circle. They're just not going to go in the part where it overlaps. Okay. So look, here's my A, my E, and my H. Okay. Now, B also has some letters. B also has the letters, what, C and D? So I'm going to put those in the circle for B as long as they're not in the overlap part because they don't overlap with A. Okay. Now, what I want to know is what letters do we still have left? Now, I've scratched out a whole bunch of letters. So let's see what other letters we're still going to have left. Now, we scratched A, we scratched B, we scratched C and D. We scratched E already because we've used it. We've used F. We have not yet used G, but we did use H. Okay. We haven't used I, we haven't used J, and we haven't used K. So those letters are the letters that we still have left. Now, those letters, y'all, they are still in the universal set. They're just not in the circles for A and B. So what we're going to do, we're just going to put those letters down inside the box, but not in the circles. So I have a G, we have an I, a J, and a K. Where do you put them? It's not really important. Just throw them in the box as long as they're not in the circles. You know what? You're right. We did use J. Oops. So let's get rid of that guy. Just kidding. Yeah, we had already used J. There we go. So G, I, and K. And there are letters. There's my Venn diagram. Does it make sense how we're able to draw it out? Yeah. Okay, just checking. Okay, so let's take a look at the next one here, y'all. It says, let U represent the set of animals in U.S. zoos. Let A represent the set of animals in the San Diego Zoo. Describe a complement. Okay, so just so we know what's going on here. The universal set are animals in U.S. zoos. And A are the ones in the San Diego Zoo. What we want to know is, what would these over here look like? If these are the ones in the San Diego Zoo, what would the complement be? Anybody know? How could I describe that? If I know that set A is all the animals in the San Diego Zoo, in the big picture, we're talking about all the animals in the zoos in the United States. What would be the rest? How would I describe the rest? You know what I mean? That's what I'm trying to figure out. Anybody know how we could describe the rest? Except for the ones where? In San Diego, right? Very good. Very good. So these are all animals. That's not the way you spell animals. See, guys, I can't teach elementary school because I can't even spell. All animals in the zoos except for the one in San Diego, right? All the animals in the U.S. zoos except for the San Diego Zoo. Okay. All right, cool. All right, so we're going to do another problem, kind of similar. Again, we're just trying to write a description. We're just trying to figure out, do we know what this is talking about here? So the first part here says, look, let's let U be the set of cities in the United States. All the cities in the United States. New York City, yes. Baltimore, Maryland, yes. San Diego, California, yes. La Villa, yes, right? All the cities in the United States, okay? Edcal, Chelsea, yes. Edinburgh, yes. All the cities, right? Okay, A is a set of cities that have professional sports team. B are the set of cities that have a symphony. Now, we want to know, what does this part here mean? A union B. So y'all, just to get a visual again, just so that I know what I'm talking about. Look, here's A, here's B. That's my universal set. When we're talking about A union B, visually, this is what we're doing. Okay? That's A union B. Now, did I shade everything in A? Yeah, did we shade everything in B? Okay, so what we're looking for here are all the cities that have A was what? Professional sports team? Or a symphony, right? So like San Antonio has a symphony. San Antonio also has a professional sports team, the San Antonio Spurs. So San Antonio would be one of those cities there, right? Houston has multiple professional sports teams. They also have symphonies. Those cities would be there, right? And then you might have like McAllen. McAllen has a symphony, but I don't know necessarily McAllen has a professional sports team, maybe a soccer or something like that, right? Maybe. So that might go in there too, but maybe not. Okay. But anyway, as long as they have one or the other, we're good. Now, what we want to do for the second part, y'all, is A intersection B. So again, just to give you a visual of what A intersection B looks like. So here's A, here's B. Okay. There's my universal set. This is what A intersection B looks like. Okay. A intersection B means we're looking for the parts that overlap, right? So like I said earlier, McAllen has a symphony, that would go in the first set, okay? If you can find a city that has a sports team but doesn't have a symphony, that would also go in the first set. And if you had a city that had both, that would also go in the first set. But for the intersection, they have to have both, okay? So these are going to be the cities that have both a professional sports team and a symphony. Okay. The main difference between the union and the intersection, the union says as long as you have one of them, you're good. If you have both, that's great. The intersection means you have to have both parts. You got to have both parts in order for it to be in the intersection, okay? It needs to have both a professional sports team and a symphony, okay? All right. So what I'm going to do here, y'all, for this next problem is we're going to use this Venn diagram, that picture right there, to list the set of elements in roster form. All it means to roster form is this is write out the letters, right? Write out the letters are going to be in the set A. Okay, so in this case here, all I want to know, what letters are inside the circle of A? A. If I were to, I mean, I don't really need to do alphabetical order, but A, H, everybody agree W, C, okay, yeah, C, B, and T. That's what we're looking for. All the letters that were inside the circle of A. Okay, I know A and H were also in B, but it does not mean that they were not in A. They were still were. Okay, now look at 36. 36 says, let's list all the letters that are in the circle of B. So we're still going to have A and H, but we're also going to have F, yeah, B, G, R, and D. And y'all, it doesn't really matter what order you put them in, but if in your homework problem, if it says, hey, list them in alphabetical order, then put them in alphabetical order. But the order in what we put them in is never really important. Okay. Now, 37 says A intersection B. The intersection, y'all, is the part where we overlap. What letters overlap? A and H. Very good. Okay. All right, so I'm going to zoom out a little bit so I can do the rest. Okay. Now, 40. 40 says A union B, but complement. So again, just to get an idea of what A union B looks like, a little while ago, y'all, I drew a picture over here for us. Here is what A union B looks like. So we picked everything that was in A, we picked everything that was in B. That's what A union B looks like. So if we were going to look at the complement, does everybody agree the complement would be everything outside of that green area, right? So look, if I were to come back over here, who would the outside be? What letters are outside those two circles? The PMZ, aren't those letters right here, y'all? Outside of that circle, does that make sense? They're outside of the two circles, right? So that's P, M, and Z, because those letters are outside of the circles, right? The union, again, just to give you a visual, y'all, if here's A and here's B, then A union B is everything shaded inside the circle. So then the part that would be the complement would be that part. Anything that's outside those two circles, but it still has to be inside the rectangle. Okay? Still has to be inside the rectangle. Okay, so now look at 41. 41 says A complement intersection B complement. Okay, so I'm going to clean up some of this mess right here. Okay. And I want us to think about what A complement would look like. A complement would say, let's pick all the letters that are outside of that circle, okay? So I'm looking at every letter outside of that circle. So right now I'm looking at the letters F, V, R, D, G, P, M, and Z, right? Everything outside the A circle. Now, the other part said, it didn't just say A complement. Let me scroll back up here. It also said B complement. Okay, so look, let's look at B complement. B complement would say, I'm looking at everything outside of that circle. So all the letters that are outside of that circle would be W, C, B, T, Z, M, and P. Okay. So now I have a visual. Now, the intersection, y'all, would say, what letters did I underline twice? What letters got underlined twice? Are any of the letters get underlined twice? Which ones? Look at the letters that we underlined. Did we ever underline P, M, and Z, right? Those letters right there are the letters that we underlined twice. Now, again, y'all, one thing I want to do here, and I'm going to go ahead and write this down. Okay, so y'all, when you're doing a problem like this, if doing it using the picture makes it difficult, then what I would say is your other approach, y'all, that we could do would be to do this. So I'm still going to use the picture, okay? Still going to use the picture, but remember what A complement means. A complement means pick every letter that's not inside that circle, okay? So then if I was going to do that, I would say, hey, look, my A complement, if I'm going to pick every letter outside that circle, F, V, G, R, D, and then also the PMZ, okay? And then I would do exactly the same thing for B complement. But the way I would do B complement is I would circle everybody right here. And I would say, okay, I want to list all the letters except the ones inside that green circle. So I would pick W, C, B, and T. W, C, B, and T. But I would also pick P, M, and Z. And now if I have a list and I want to say, and I'm just going to try to zoom out a little bit, but I want to say, what does A complement and B complement intersection look like? It's just saying, what letters do they have in common? Okay, so that's another way you can go about doing it. Which way is easier? That's all going to depend on you. Okay, if you like using a picture, hey, use a picture. And I think a lot of times the picture works really well. But sometimes if it gets too much, make a list, and then you can do it that way, right? And there's no wrong way or right way to do the problem because you're both going to end up with the same answer. Okay, so now let's take a look. We got two more parts here, A minus B and A minus B complement. Okay, so look, I'm going to come back over here, y'all. And I want us to get a visual of what A minus B looks like. A minus B says, I want to pick letters in A, but I don't want the ones that are in B. What letters would I be picking? So what letters are in A, but not the ones in B? Does that make sense? Those letters are in A, but they're not in B, right? So I'm going to pick W, C, B, and T. Okay. So for this part right here, I'm going to pick W, B, C, and T. Okay. Okay, now for 44, it says A minus B complement. Okay, so you know what I'm probably going to do here, y'all? I'm going to come back over here, and I want to know, what does B complement look like? Okay. B complement, y'all, says pick every letter. Let me clean up this other mess over here. Okay, B complement says pick every letter except for those. Every letter except for those. So I'm going to pick W, C, B, T, P, M, and Z. Okay. And now, if you remember what we're looking for A minus B complement. Now, the very first problem we did, we made a list for A. A was right here. Here is our B complement right here. I want to pick letters that are here, but that are not over here. So I'm only going to pick from this group. Y'all agree I would pick A and H? But would I pick the WCBT? No, right? So it's just going to be A and H. So right here, y'all, we're just going to pick A and H. Okay. And so again, if it helps to write out the list, write out the list. It does make it easier in certain cases, I think. Okay. All right. So let's try the same thing here. We want to find the intersection and then the complement of the intersection. Okay. So if I look at the first part, y'all, A intersection C. Remember what A intersection C means? It just means what letters, oops, not for B, but for C. What letters do they have in common? So the letters they have in common so far is A and F and I. A, F, and I. Okay. All right. So, question. Does anybody know what would the complement look like? Or how would I find the complement? I want to pick every letter here, except for which ones? Anyone know? Do we know what this looks like here on the inside? Yeah, we want to pick every letter except for A, F, and I, right? So we're going to start with B, C, D, E, not F, but G, H, not I, but J, and K, right? And that's what the complement means, right? So again, y'all, in order to find the complement, I have to know what the original set looks like. And the way I find the complement is go back to the universal set and say, pick those letters that are not in the original one, right? Excellent, excellent. Okay. So it says for the diagram to the right, which is the correct notation, okay? So when we're looking at here, y'all, we're looking at what is the correct notation. So first thing I'd probably do is I'd probably come back over here and I'd look at this picture, okay? And just looking at what they shaded this part here and they shaded that part there. That looks like to me that they picked the letters that were in what set? Oops. They were in K, but they were not in what set? In A, right? So it looks like we picked the sets, the letters that were in K or whatever elements we had that were not in A. Coming back over here, which one looks like it's K but not A? B, right? K and not A would be B, right? We're picking everything in K, but we don't want the stuff to A. Okay. Now, there is a second problem. Second problem looks like we have everything outside of the set A and everything outside of the set K, right? Everything out of the union of those two sets, right? Because I know the union of those two sets would be everything here, and we picked everything except for that. So it's kind of like we did A union B, and then we did the complement. So first thing I'm going to do is, do I have something that looks like this? Do I have something that looks A union B, and then the complement? No, because everything here happens to be intersections. Okay, so then what I'm going to do, y'all, is I'm going to start drawing some pictures. So look, I'm going to draw a picture right here. I'm going to call this my set A. I'm going to call this my set K, okay? And the first thing I want to do, I'm going to look at the first part right here. A complement. Does everybody agree that A complement would be everything outside of the set A? Everything outside that circle, right? Okay. Now, second thing I want to look at is, what would K complement look like? Well, K complement would say, I want to take everything outside of that circle. So if I were to do everything outside of that circle, this is what we would be left with, okay? Everything outside of that circle. Now, my question to you, the intersection says, what parts overlap? Is there an area that we shaded twice? Didn't we shade everything outside of this circle and everything out of this circle? Didn't we shade all of that already twice, right? So, and that's exactly the same picture that I have right there, because that's the part that we shaded twice, everything outside of that, right? So I'm no longer looking at this right here, and I'm no longer looking at, oops, I didn't mean to do that. That right there, I'm only looking at that piece. So then my answer here, y'all, would be the first one, okay? And I would just go through the different case scenarios, draw some pictures, right? Doesn't take a whole lot of effort, draw some pictures. And if I know what those definitions look like, y'all, again, one thing I want to mention, how did I know that that was a complement? Oh, I'm going to scroll back over here. Oh, man, let me see if I can find it. Difference. Probably at the very, very, very top. Here we go. Here we go. At the very top, I said sometimes they use a little bar on the top to let me know that that's a complement, okay? So that's how I knew that that's what it was, okay? So when you're doing your homework, sometimes it'll have a little apostrophe, sometimes it'll have a little line, but they both mean the same thing, okay? All right, so let's keep moving along here, because we got a few more problems to do. Okay, so the next part here, y'all, says complete parts A and B for the following set. P complement intersection B complement. Hey, when I look at this piece right here, doesn't that kind of look like, here we go, that piece right there? The letters are different, but it's the same kind of thing, right? So what does the picture look like? The picture needs to look like that picture right there, right? So what am I going to shade? Everything outside of those two circles, right? Everything outside of those two circles. Now, y'all, when you're doing your homework, it's going to allow you to click on a little thing and it'll pop it up like this, and then you get to decide what part you're going to shade, but that's what you're looking at, okay? All right, so let's see. Now, the other thing we're looking for is there another way we can write P complement intersection K complement? Well, one way we did it earlier was like this with the union, but I don't see one with a union here, okay? So let me see what else we got. So what I'm going to do, I'm going to draw a circle or two circles in my Venn diagram. I'm going to call this one here P, because I believe that's how they labeled it. I'm going to call this one here K. All right. Now, all I'm going to do is I'm going to see which one of these looks like it's going to match up. Now, the first one, K minus P. K minus P would mean shade just what's in K, but not in P, and that's not what I have. So I know that it's not that one there. Okay, so look, let me clean this up. I don't need it, but I know that that's not going to be the one I'm going to use. Now, the second one says P complement minus K. Okay, P complement, y'all. P complement would mean I'm going to shade everything outside of this green circle. Okay, I'm going to shade everything outside of the green circle, but I don't want to include the letter K because we're subtracting that K, right? So I don't want to include the K. So I'm shading everything outside that green circle, but not the K. Does that look like the picture that we have? Yeah, it kind of does, right? So my choice here, y'all, is going to be that P complement minus K. All right. So now, y'all, I got a couple more problems. These are more like application type problems where we're still using this idea of unions and intersections and so on and so forth. So let's read through the first problem. Let's see if we can't figure this thing out. It says, the Greens are moving to Athens, Georgia. The real estate agent located 77 houses listed for sale in the Athens area in their price range. Of those houses listed for sale, 47 of them had a finished basement, 52 had a 3-car garage, and 35 had a basement and a 3-car garage. Okay, the question says, how many had a finished basement but not a 3-car garage? How many had a 3-car garage and not a basement? And how many of them had either a finished basement or a 3-car garage? Okay, so y'all, the way I'm going to do this problem, we are going to draw a Venn diagram. We're going to draw a rectangle, okay? This is going to be our universal set. And we're going to have two circles here, okay? One of them is going to be for a basement, and one of them is going to be for a garage, okay? So I'm using the letters B and G for basement and garage. Okay, so y'all, the way I fill this part in, I'm always going to fill in the overlap. So the overlap is going to be the part where they had both. So notice it says 35 had a finished basement and a 3-car garage. So I'm going to write that number 35 right here in the middle, y'all. Okay. Now, the next part I'm going to look at is this 52 had a 3-car garage. Now, y'all, what that means is that everybody inside this circle has to add up to the number 52. But inside there, I already have what number? Okay, so this is what we're going to do. We are going to, we're going to subtract, right? I kind of make this a little bit better. But anywho, 52 minus 35 is leaving us with 17. Very good. So right here, y'all, we're going to put the number 17. Now, 47 had a finished basement. That means that everybody inside this circle has to add up to the number 47. Okay, so I'm going to open this up again. And we're going to do, what was it, 42? 47. 47 minus 35, 12. There we go. So that number right there is going to be 12. Okay. Now, do we know how many houses they showed us in total? Did they tell us? Yeah, they showed us 77 houses. So all the numbers that I have to add up to the number 77. So look, y'all, I'm going to grab my calculator. I'm going to use this one because I don't know why the other one's coming out all funky. But let me turn this guy on. Okay, clear it out. Okay, let's go 12 plus 35 plus 17. That adds up to 64. So everybody inside those circles is 64. But we know that we had a total of how many? Okay, so look, y'all, we're going to take 77 minus 64. That's leaving me with 13. What that's telling me is that those 13 houses did not have a basement and they did not have a 3-car garage, but there were still houses that they showed to them, okay? So my first step, y'all, I'm always going to draw my picture. Once I draw my picture, I can come back and answer the questions. So look, part A says, how many of them had a basement but not a 3-car garage? So how many were in the basement area but not in the garage? Anybody know? 12. Look at those numbers right there. That 12 tells me, hey, those have a basement, but they don't have a garage. Okay. How many of them have the 3-car garage, but not the basement? Anybody know? 17. Okay. And how many of them have either? Either, you all, are those numbers added up together. All of those numbers added together. As long as it falls in one of those circles, we're good. If it falls in both, that's fine too. So when we added up all those numbers, y'all remember what we came up with? 64, right? So that's my answer for the last part. Okay. All right. So guys, I'm going to do this process every single time. Okay. I'm going to do this process every single time. So look, I'm going to jump to another problem. Okay. And it says resorts. It says in a survey of 92 resorts. So again, first thing I notice, y'all, my total number is going to be 92. It says 27 of them had a spa, 55 of them had a fitness center, 38 had a children's club, 13 had a spa and a fitness center, 10 had a spa and a children's club, 19 had a fitness center and a children's club, and 7 had all 3. Okay, so my first step, y'all, I'm going to draw a big rectangle. Here's my big rectangle. And in this case, y'all, how many circles do you think I'm going to draw? 3. We got spa, fitness center, and children's club. So look, spa, I'm going to do a different color, fitness center, and children's club. Okay, so spa, fitness center, and children's club. Okay, the way I'm going to do these, y'all, I'm actually going to work my way from the bottom up. Look what it says. 7 had all 3. What I want to know is if I look at those circles, the part where all 3 circles overlap, everybody agree is that section right there? That's where my 7 is going to go. Okay. Now, the next piece I'm going to look like, it says 19 had a fitness center and a children's club. Okay. So look, y'all, here is the fitness center. That's my circle for fitness center. This is my circle for children's club. This is where those 2 circles overlap. Those 2 circles overlap right there, and that number has to give me a total of 19. So if this already has 7, do y'all agree that that number there would have to be 12? Because then that would give me the total of 19. And all we did is just subtract, right? 19 minus 7. Very good. Okay, look at the next part. It says 10 had a spa and a children's club. 10 had a spa and a children's club. So here's my spa circle. Okay. Here's my children's club circle. So those 2 circles overlap right here, y'all. And that overall number has to add up to 10. Well, if that piece is 7, that one's going to have to be 3, isn't it? Okay, awesome. We're almost done. The next part says 13 had a spa and a fitness center. So here's my spa, and here's my fitness center. So those 2 circles overlap in this piece, and that number has to add up to 13. And if this number is 7, that's going to have to be a 6. Very good. Okay. So now the next part, it's telling me that 38 had a children's club. So everybody in the children's club circle has to add up to 38. So what I'm going to do, y'all, I'm going to add those numbers up first. I'm going to say, look, we got 3 plus 7 plus 12 is 22. Now I'm going to take 38 minus 22, 16. That's going to be the number for the children's club. That's going to be the number that's going to go right there. Okay. Then the next part says 55 had a fitness center. So everybody in that circle has to add up to 55. So let me take the numbers that are in that circle. So 6 plus 7 plus, what is that, 12? Okay, and we're going to go 55 minus that answer, 25, that's 30. That's going to be the number that's going to go right over here, okay? And we got one last one to do, y'all, spa. So everybody in the spa circle has to add up to 27. So again, let's go 3 plus 7, 7 plus 6 is 16, and that number has to add up to 27. So 27 minus 16 should be 11. That number is going to go right there. Okay, now, guys, we still have one last number to do. The one last number is going to be the number that's going to fall inside the box, but outside the circles. So the way I'm going to do that, I'm just going to add all the numbers in the circle up. So look, let me clear this out. I'm just going to go 11 plus 3 plus 7 plus 6 plus 30 plus 12 plus 16. Is that all the numbers? Okay, so let's add all those numbers up. Look, we got 85, right? But the total number was how much? 92. So let's go 92, very good. Minus 85 was how much? 7, right? Okay, so that 7, y'all, is just going to go somewhere over there. Okay, now that we did that part, it's easy for me to answer the questions. Part A says, how many of them only had a spot? Only the spot, nothing else except the spot. What number is inside the S circle, but it's not in any of the other ones? 11, very good. Okay, now, part B says exactly one of those features. Exactly one of the features, y'all, is going to be the number that it's going to fall in exactly just one part of the circle. So I'm going to take those three numbers that I just circled, 11, 30, and 16, and we're going to add them up. So 11 and 30 and 16, 57. That's going to be the number right here. Now, at least one of the features, y'all, means it can have one of the features, or it can have two of the features, or it can have all three. What that means is all the numbers inside the circles together. Now, we added them up earlier. And anybody remember what we came up with? 85. So 85 would be at least one. Now, part D says exactly two of the features. Exactly two of the features, y'all, is talking about the numbers that appear only in those sections right there. That's going to be the exactly two. Okay, so exactly two would be those numbers right there. And if we add 6, 3, and 12, what's that, 21? Okay, excellent. Okay, and then part E, y'all, says none of the features. What number was outside the circles? Very good. And you got it. Okay. Now, I know, guys, is the question, before we go on, has anybody ever seen these problems before? If you have, raise your hand. If not, okay. You had already seen it before? So when you haven't, y'all, the hardest part to me is drawing the circles. But once you draw the circles, it gets easier. So look, I think we got 2 more problems to do like this. Let's see, 1 and 2, okay? And I guarantee you, by the time we get to this one over here, it's going to seem very easy breezy cover girl to us, okay? So look, let's try this one here. I'm going to go about it exactly the same way. But again, anytime something is new, it always seems harder than what it really is, okay? All right. So the next problem I have says book purchases. A survey of 85 customers was taken at Barnes & Noble regarding the types of books purchased. It said the survey found that 44 bought mysteries, 33 bought science fiction, 29 bought romance, 13 bought mystery and science fiction, 5 bought science fiction and romance, 11 bought mystery and romance, and 2 bought all 3 types. Okay, so my first step, draw a big rectangle. And we're going to do our 3 circles. So mysteries and science fiction and romance. Okay. So let me go ahead and write that out. Mysteries, science fiction, and romance. Okay, y'all. So when I do this, again, just a reminder, I always start from the bottom going up. So look what it says. 2 bought all 3 types. So where all 3 circles overlap, I'm going to write the number 2. Okay. Now it says 11 bought mysteries and romance. Mysteries and romance would be this piece right here. That's where those two circles overlap. And that number right there, y'all, has to add up to 11. So if this number is 2, everyone agreed that that number there would have to be a 9, because 9 plus 2 is 11. Okay. And then it says that 5 bought science fiction and romance. 5 bought science fiction and romance. So here's science fiction and romance. This is where those two circles overlap. Okay. That number has to add up to 5. I know that's got to be a 3. Okay. And then it says 13 bought mysteries and science fiction. Mysteries and science fiction overlaps right here. And that number has to add up to 13. If that's a 2, that's got to be an 11. Okay. All right. Now we can go strictly to the romance. It says 29 people bought romance novels. So everybody inside the romance circle has to add up to the number 29. So let's take those numbers. 9 plus 2 plus 3. That gives us 14, and we're going to take 29 minus 14. It's going to give us something like 15, right? So 15 is going to be right there, okay? Then it says 33 bought science fiction. Okay, so science fiction, everybody inside this circle right here, y'all, has to add up to 33. So look, let's take 11 plus 2 plus 3 and subtract it from 33. So 33 minus 16, 17. Very good. So that number is going to go right over here. And then 44 bought mysteries. So everybody inside this circle here, y'all, has to add up to 44. So we're going to take 9 and 11 and 2. Is 22, and we subtract it from 44, and we're still going to get 22, right? Okay. And then finally, y'all, we got to do one last number. The whole total was 85. So I got to take all these numbers inside those circles, add them up, subtract it from 85, and that will tell me the number that's going to go on the outside. Okay, so look, let's take those numbers inside the circles and start adding them up. So I got 22 plus 11 plus 2 plus 9 plus 17 plus 3 plus 15. Okay, 79. And we said the total was what, 85? So 85 minus 79 should give us a total of 6. Yep. And that's going to be our number, y'all, that we're going to write over here on the outside. Okay, so now that we have that part right there, y'all, we're going to look for only mysteries. Which number only is mysteries? 22, right? Because that's the number that's right there, only in the mysteries. Okay, look at part B. It says mysteries and science fiction. Mysteries and science fiction. That's going to be where they overlap right here, y'all. That's where they overlap. But it says mysteries and science fiction, but not romance. So I know that they overlap here, but I only want the mystery and the science fiction. I don't want the romance. What number would I use? 11. Very good. Okay. Now, part C, y'all, says mysteries or science fiction. Mysteries or science fiction would be anybody in that circle and anybody in that circle. So I'm going to just take those numbers, y'all, and I'm going to add them up together. So look, I'm going to clear this out. I'm going to say, look, let's take 22 plus 9 plus 11 plus 2 plus 3 plus what, 17? Okay, because as long as they fall in those two circles, it's still mystery and it's still romance, right? I know it didn't say, mysteries or science fiction, sorry. So anybody that fell in this circle and anybody that fell in that circle. So that was a total of 64. Okay, now part D says mysteries or science fiction, but not romance. What that's talking about, y'all, is they're saying, look, let's pick these numbers. So look at what I'm kind of trying to highlight here. So the only numbers I would use would be which ones? So mystery or science fiction, but not romance. I'm only using the numbers, what, 22, 11, and 17? Very good. Okay. And that's the advantage of having the picture, y'all, is it just makes it so much easier to do. 50. Okay, so 50 right here. Now, exactly two types, y'all. Exactly two types are 9, 11, and 3. So that would be how much? 23? Because 9 and 11 is 20, and then another 3 is 23, right? Okay, awesome. Very good. Okay, so look, y'all, we got one last problem to do here out of 2.3. So let's go ahead and do it to it. And hopefully by the time we get to this one here, hopefully it seems a little bit easier because we're kind of getting the hang of it. So look, let's do this. And we're going to have our 3 circles again. 1, 2, 3. Okay, and so we have people that cook food. We have people that wash dishes, and we have people that did the cash register. So those are the food, these are the dishes, folks, and those are the cash register. Okay, so I think this problem is going to be a little bit easier in the sense that the numbers are small, okay? The numbers are small here, y'all. So look, we're going to work our way from the bottom all the way up to the top. Look what it says. 2 did all 3 jobs. Everybody agree that number right there is going to be a 2? Okay. 3 cooked food and did the cash register. So look, here's my food circle and my cash register. This is where they overlap, and that number has to give me a total of 3. So everybody agree that one will have to be a 1? Okay, cool. And then 5 did the dishes and the cash register. So here's my dishes and my cash register overlap. That has to add up to 5. Everyone agree that's going to have to be a 3? Okay. And then it says 4 did cook food and wash dishes. So this piece is going to have to add up to 4. That's going to have to be a 2. Again, numbers are really small here, so it usually makes it a little bit easier. Now, the next part here says 18 operated the cash register. So everybody in this circle here, y'all, has to add up to 18. So look, let's clear this out. Let's go 1 plus 2 plus 3. That's going to give me 18. So 18 minus 6. That's going to give me 12. Very good. So that's going to go right there. Okay. 9 folks did the dishes. So everybody inside this circle has to add up to 9. So we can say 2 plus 2 plus 3 is 7. And if it has to add up to 9, that's got to be a 2, right? And 8 cooked food. So everybody inside the food circle has to add up to 8. So that's 2 and 2 is 4, and 1 more is 5. That has to be a 3. Okay, and then we all remember, I'm going to write a number over here in that little corner somewhere because it's going to be outside of those circles, right? So the way I'm going to do that is clear this out. Okay, let's just go on 3 plus 2 plus 2 plus 1 plus 2 plus 3 plus 12. That adds up to 25. But how many employees did we have? 30. So that number right there has got to be a 5. Okay. Let's see. Question. How many people only cook food? 3. What about only did the cash register? 12? Okay. And then how many washed dishes and did the cash register but did not cook food? So look, y'all, what it's telling me, wash the dishes and did the cash register. So those 2 circles overlap right there. Dishes and the cash register, but did not cook food. I don't want that piece. So what number am I going to use? Just the 3, right? Just the 3. They washed dishes, they did the cash register, but did not cook the food. Okay. And I believe that is 2.3, y'all. Okay, so I hope these problems made some sense. I'm going to go ahead and I'm going to stop recording. Actually, before I stop recording, y'all, so remember, the homework is due a week from tonight, right? So don't forget, y'all, 2.1, 2.2 due by tonight. 2.3, what we just got finished doing, is not due until next Wednesday. And then, y'all have a quiz on chapter 2. So let me just do this real quick. Let me click on this deal. Um, and the quiz, again, guys, you have 90 minutes, so you got a whole lot of time to get it done. So if I click on assignments, here's quiz number 2. And I'm just curious how many questions are on there. 12 questions, right? So you got 90 minutes to do 12 questions. You got 3 shots at it, right? So plenty of time to get the stuff done, all right? But anywho, just want to give you all a heads up on that. Let me go ahead and stop recording.